Hello, welcome to Automat Live Coding. During the last stream, we have been working on this. This is our master plan for how to improve Automat rendering infrastructure. It's going to give us two very big things. First, if there are any slow widgets on screen, like there are now, because right now we have connection widgets which are super slow. They're compiling shaders. And we could fix that, right? We can fix that in an hour. In an hour the issue will be gone, Automat will be rendering super fast again. But we can use this opportunity and actually make sure that Automat always runs fast, even if there are some misbehaving widgets. The way we will do this is that in the widget tree, we will actually measure the draw time of each widget. And each widget, they already are, but we can cache the rendering results of any widget into a texture to avoid re-rendering. Only animated widgets, when they are animating, they need to be re-rendered continuously. So we have this tree of textures and we know how long it takes to render each widget. So the plan that we are following, we've been doing this over the last stream, and I think today we will finish, is that we are actually trying to deliberately pack a frame with render tasks that should fit below 16 milliseconds. Any extra work, because there is always extra work, let's be honest, is added into an overflow list. So the client, when a frame starts, it sends a client being some display device request that, hey, I need to render a frame, tell me what should I draw. Then we, in Automat, we are doing the frame packing, this is our algorithm for frame packing, and we are sending a response with the list of frames. And then the client displays this. After display, they started drawing the overflow widgets because they're like, usually the client will be faster than, serial rendering. The client can render stuff in parallel, it's not an issue. But anyway, so the client eventually gets interrupted because the time for the new frame comes, and they send another pack frame request. This time they include the results of the previous frame, so which drawables were drawn and how long it took to draw them. Right. Fairly simple, but I haven't seen this literally in any GUI framework. I'm not even familiar with any games that would use something like that. I think so. This technique is very popular in movies recently, like Into the Spider-Verse has a very unique animation style. It pretends to be stop motion, like a classical animation, but in reality it's just frozen, like a frame is frozen for a couple. The same image is frozen for a couple of frames, so we have a couple of diagrams. This is the kind of flow diagram, like how the different events flow through time, how messages are exchanged. And this is the diagram from the perspective of a single widget, because a single widget, it goes through a couple different states. I think we did change this so that when a new widget is rendered, or maybe not, I don't recall actually. Anyway, the widget can be in a dirty state. When it has to be refreshed, it can be scheduled on the client. It can be scheduled and dirty, which is a very complex state. We have to come up with a very robust rule for drawing those kinds of widgets, which we did. And only if the widget has been fully displayed and is still marked as dirty, so it should be re-rendered, only those widgets participate in packing, actually. Every other widget is either excluded or automatically included. We also have an extension of this algorithm, which also takes care of downscaling widgets, because the widgets that we have been dealing so far, they are slow because they are compiling shaders. But I imagine, like, if we fix this silly issue about shader compilation, the actual issue is going to be that the GPU is just not going to be able to keep up. I'm sure on some slower GPUs this is probably already the case. So we have this more complex version, which takes care to downscale widgets, so it differentiates between full renders and fast renders. Yeah. So if a widget is animating, we are trying to render it using a downscaled version. Otherwise, we can use full render. Anyway, let's switch to VS Code and let's start working on this. I was thinking about some of the decisions that we've made, and I don't think we should use this picture here. I think we will change some types. Here. So when we send a frame to the client, we are not going to send it as an SK image. We will send it as a sequence of SK drawables. So here widget to image. No, we don't want widget to image. What does it return? Okay, this is this SKSP. Okay, so we can get rid of all those things. Yep. I think we can always record a drawable. Okay, we will do one new thing, one very different thing. Let me just check some things. When I want to draw a drawable, okay, I can pass it by pointer. Okay, I'm looking at this because I am introducing something called Choppy drawable. This is our own drawable, which will just draw the widget using the most recently cached texture.
Hello, Hasnick. This is a reminder that TTS only works in English. Please use English in chat.
This is a stream in English. Please use English. if I remember correctly, we also need some kind of so this choppy drawable is a drawable that can switch between the most recent frame. I mean, it always uses the most recent frame, but it's also something that we can ask to update itself. Okay, I am not deriving from Skia drawable, I'm deriving from my own drawable wrapper. I am doing this because Skia doesn't have RTTI, so it's actually messing up the linking between our code and Skia code. No need to worry about that, it's just this is how we draw stuff. We will have to put more stuff here. I still don't know what exactly. I know when I press Ctrl S now, a slang formatter is going to totally mess up my formatting, but whatever. When we create this choppy drawable, we'll pass the actual
Hasnick says,
It's a delight to watch you in the zone, talking to yourself and kind of crazy genius in the eye. Inherent attributes of a good programmer. Jokes aside, love the project idea.
Thanks. And hi, by the way. Okay, we will need more stuff here, but for now this is just a wrapper, right? Could actually do. Can we do that? Yeah, we can. Okay, so now that we have those choppy drawables, actually I would like to store this as a unique pointer. Or maybe it's a bad idea, whatever, I will just unique pointer, keep this. Okay, this is copyable, so let's keep it like that. Okay, I don't know what to do with this getBounce function. I guess we should do something about this. I don't know how Skia really uses this. Is it used for clipping or something like that? I'm not sure. Okay, so here, instead of widget to image, we will have widget to Choppy drawable. Who needs this move? We can just pass a value reference. I'm looking at this and I think when we record this drawable, we probably have to start the time when it was actually generated. Let me think about those things. So I'm trying to think about this in this like two separate clients perspective. So this draw cache, I think this is something that will live on the server. And if this lives on the server, then we will have no images here. None whatsoever. So whenever we schedule something to be rendered, so we can take note of the time. I mean, we have to take note of the time, but this is also when we should instantiate this drawable of ours. And I wonder, should we store it here? We could just store the identifier. Generation ID. Yeah, I think this is what we need. Let me check how it's implemented. Okay, so it allocates a new identifier when we call it. I think this is fine. We just need to record those IDs here. First of all, we have to add this new field. Actually, instead of having two fields, we can also store just one. Notice that there are no images here, none whatsoever. Let's go here. Let's change this image to Choppy drawable. Now, if we go a little bit back, there will be a section here which we optimized, but we shouldn't have. Here, this. Okay, so we are trying to find the ID of the draw job in the results returned by the client. If we find it, so this is index, not an ID. Then we're updating the render time, and we do not return anything here. And if this is presented on screen, then we will update some of those numbers here. Let me see what they are. Oh, actually this is something slightly different. So if it's not presented, then we need to invalidate the parent. I think this should be minimum. we don't need to shuffle the images anymore. The client is going to be responsible for that, which is just another function. Okay, so we are updating the draw millis. This. I think we should also clear all of those values. Draw ID, draw time, draw present. Just so that we don't leave garbage in some properties, it can be confusing later. And this we don't need. And we also don't need these check render results. Okay. Much cleaner. Okay, so if there is any active draw job, we are skipping this entry. If it wasn't invalidated, we are also skipping it. And here maybe we should compare the presented time and invalidated time. Yeah, setting invalidated to a high value. Or to 0. Doesn't really make much sense. I think this should be set to the current time when the widget is created or something like that. And it should never be set to max. That. And let's remove this. So the initial value doesn't really matter that much. Oh, actually it does, because we want to have the earliest invalidation time here. We're using invalidated in like 3 different ways. I think we should unify that.
Axon says,
I'm looking for a new job. Windows Server Administrator. Marek, we love you 3.
Hey, Saxon. Thinking how to handle this. Maybe I will try to draw this. Or I will do this differently. I have a tiny camera here, so I can actually draw on paper. Let me see. Yeah, it works. So we are going to have to come up with some invalidation logic. So how do we... So what do we need? We need to have the lag value for frame packing, and I guess that's that. So if you look at the timeline, let's say the widget is invalidated periodically. So those are invalidations. Let's put I here. Now, I can also draw the widget. So if a widget was invalidated here, and I draw it here, like the invalidation doesn't matter. So the lag is 0 here. And between the invalidation and the draw, the lag increases, then jumps to 0. Then another invalidation happens, and the lag again starts increase. And then I draw it, it jumps back to 0. So this here, this line is equal to now minus last or first invalidation. Because here, if we had multiple invalidations, only the first one matters for the lag value. Now let's have a more complex example where you have invalidations all the time, but the drawing is very slow. So after the first invalidation, we are starting to accumulate the lag. but we already started drawing the object here. So let's say the object appears, I don't know, here. So this is our draw operation, which started here, finished here. When this happens, we still need to redraw the object because it's still invalidated by those invalidations have not been presented. So the moment we hit this point, we can start drawing object based on this content from this point in time. Okay, if I'm reading this correctly, we will have to record the invalidation times and keep them around to actually properly solve this, which is not what I want. Because then we start another draw job. Okay, so after we finished this draw job, what was the lag? The lag was this already. This lag value is tricky. I really want to do it using just a couple of counters. Let me see, maybe I can try drawing this in TL draw. Maybe this will be easier to navigate. Let's find some free space. Need a line. So this is our time. And now we have invalidation. Maybe I can make it shorter. Let's first do the simple case. So the red lines are invalidations. Let's say orange lines are going to mean the lag. Blue will be this should be orange. So this is the simple case. We have an invalidation. The lag value starts increasing. And then we present something on screen. And then the lag value jumps down to 0. So this is kind of how it looks. Oops. So this is the presentation time. Maybe I will change the colors a little bit. Black should be red. And invalidation yellow. Okay, now the case with scheduling, not scheduling, like background jobs. So if we take those things out of there, now let's say we get an invalidation and then we start rendering stuff. So the lag starts growing until we finish rendering and there is the present event. But when we do the presentation, the lag isn't really fully 0 because that earlier invalidation still counts. And if there were multiple invalidations here, actually no, if there were multiple invalidations, the lag will count from the earliest one. But when we start a next job now, that job is actually going to pick up from this one. So the actual lag is actually going to follow this line here. I mean, it will drop to 0 actually, because there were no invalidations. But if there were like a new invalidation here, then the lag would look like that. I can put this on top. Makes more sense to put it here. Okay, so when I send a draw job, okay, I think we will be able to do this using just a couple of counters. I don't think we will have to keep track of everything. So lag is equal to current timestamp minus this invalidation timestamp. And when we start rendering, we should record the time when we do this start. Okay, we need 2 timestamps, I think. So the first one is going to be used to calculate this value, but there is another hidden. This is the earliest invalidation time. I will pick better names for them in a moment. Okay, so when drawing is presented, okay, so this is the basic logic that we have to follow, but we actually don't need two counters because we are only interested in the lag before the drawing starts. So I think this feels like this could be confusing, but we don't need two timers. When the drawing starts, we can just set the invalidation time to max. And that should have that should be sufficient. Okay, let's document this. Okay, so those are some small reflections about lag. Okay, looks good. Which is crazy because it seems like I already figured this out a long time ago. Initially set this to 0 and with this scheduled set this to max value. But okay. We can combine probably those two loops. Do we do packing here? I don't... Okay, we do, yes.
Simon24 just followed on Twitch.
Hey Simon, thanks for the follow. Okay, this is actually... This packing, I think we are doing this alright. This rendered matrix, seems we are changing this only when we actually update the object. I can do it here, sure. And then another thing we wanted to do was to clear the invalidation timestamp. This will ensure that from now on the lag is going to be 0. Okay, so our frame pack request now looks and response, they look very different than before. They include those choppy drawables. And the choppy drawable will have a function which will actually take care of the drawing. Here.
Says, hello Jarek Jaro. This is a reminder that TTS only works in English.
That's true. This flash and this submit, we will actually do this within the update function. I'll worry about this later. So this is Discord on my side, don't worry. It's not your PC. Okay, and within those Choppy drawables, we can actually store extra information that will be sent to the client, and that can help us with bookkeeping. So when we are done, we are going to call canvas.drawable. Okay, I can pass position or the whole matrix. If we manage to see something on screen today, this is going to be a good day. I'm going to be happy if I see any rendering happening whatsoever. So here we update the image and flash it to the GPU. And here we will actually draw using the cached texture. I don't think we have to go through a picture here. We can probably just render straight to a surface. I actually wonder, does the graphite backend use SK surfaces? Because I'm going to switch to this backend, so I want to be sure. Can I see more context? I'm pretty sure there should be an option somewhere here to show more lines. We are definitely using SK surfaces here. So let's go back to core. Let's see. How can we convert drawable? Okay, so we can draw this, right? So this will actually cause an immediate drawing. I need to pass a canvas here. I remember during the last stream we found something interesting about frame, not frame present, something about frame present time. It had to be in the GPU directory. Frame boundary. gr submit info. Okay, so if we just use this submit, and we can submit to anything, I guess. So we are flashing the whole context here. Okay, so I guess we can use surfaces. I think when we have this context, we can somehow create surfaces from this. Yeah, there was SK surfaces. And this backend texture. Okay, once we have this backend texture, I guess we should be able to get somehow a surface or a canvas out of it. Not necessarily. If I remember correctly, there was a way to ask the canvas to make surface exactly. Do we actually have this here? All of this here? I'm reducing the number of kind of operations, crazy operations that we do, like sending work to another thread. Let's just skip it for now. So here we are actually building the drawable. I mean, look at this, we are only using this in this one place. And it's actually commented out right now. I'm doing this in a very lazy way right now, where I have the full canvas bounce here. It should really be the bounce of the object. I remember I am storing some of those values within the object itself. So I have a local bounce, root bounce, some matrices, I wonder about those bounds here. Yeah, I think we should use that here. those bounds are integer bounds. I don't know, I actually think I will be able to round them here. Yeah. I should not need any fake context here. But I should need a fake canvas. So during the update, we are drawing the actual drawable. We have no phases here, so okay, we will have to fix this function. There is probably so much wrong with, especially with the bounds of widgets. But this on draw is something that we can probably do now. I want to look at this again here. So we have a tree of widgets, right? Which we are scanning to create jobs. But a job is actually a choppy drawable. So some of them will have drawables attached. Some of them which don't have any texture size, they will not be cached in surfaces. So here we are actually executing the draw commands. So when we will be drawing children of an object, or this draw cached, this drawing should actually happen from within the, like Choppy Drawable is responsible for that. That would mean Choppy Drawable should become part of the widget. Should the widget itself become a Choppy Drawable? Probably not, but it should probably hold the referenced one. Here, when we convert a widget to Choppy Drawable, really we should just return the Choppy Drawable itself. So with each cache entry we have this here. This is going to be a little bit messy, but eventually it's going to clean up itself. So let's add Choppy drawable here into widget. So instead of storing this ID, you can also store the Choppy drawable itself. Come on. I just want a unique pointer. They forced me. It's a regular pointer. because it's in a couple of places, let's just make it shared pointer. Just to be sure. This massive code, this we can delete. Those measurements, we don't need them. Actually, rendering to escape pictures, don't need it also. I will only keep this render to surface, get rid of time measurement. Just deleting unused code. So when a widget is being drawn, I'm thinking of new ways to simplify all this, but first I want to get it to work. So some of the ideas would be, where do I record them? Maybe I can record them here. This feels like a good place. Oops, no. Or maybe not. Maybe it should include drawables. Okay. Let's continue. Let's fix just the compilation. Let's make it compile. So by the way, this doesn't work right now. We'll have to still investigate whether the stuff that we are sending over it, whether it makes sense. Let's see. Weirdly, we see something. It's just, it's mostly nonsense. Oops. Let's see how this looks. Rendering image 6840, blah blah blah. And then 6841. Okay, and we are recording information about which widgets are packed in each image. So the root object, the window, is always packed. We forcefully pack it because the client expects at least one widget here. It's not looking that bad actually. But we should investigate what's happening after we pack the frame, when we do this image rendering. So here is where we call update. We can actually just run debugger to step through to see what's happening. I'll be right back. So what image are we are rendering? Image 1. Great. It's actually not image. It should be so this is our drawable. Measuring time, and we are entering the update function. I see some pointless things that we are doing. So here, so there are actually 3 points in the lifetime of rendering. So first of all, there is this point here. This is where we emit the drawing commands. And we don't really need any separate drawables here. Or maybe we could have it. Yeah, let's have it. So we need a class like Choppy drawable, because this is the only way that we can actually change the behavior of drawing under the hood, to sometimes draw the actual stuff and sometimes draw the surface. So this class is definitely necessary for us. So this is not the actual drawable, it's more like it's more of a recording of how the widget. So there is first the recording time. So this widget to Choppy drawable, essentially recording stuff. Since this function is only called in one place, there's no reason to have a function. My mouse is going crazy. Okay, we are not going to use any shape pointers, it's just going to be like a copy. And here we will have just a default constructor. Like all of this is just going to be initialized to null pointers. And actually, this shouldn't really store any data. I think the more data we store here, the more problems we'll have. We should store all the data in draw cache entry. That should be just a wrapper around something. This draw cache entry essentially, and the recording. Okay, we are not moving those entries, that's fine. All of those we should move into implementation file. Okay, now within the Choppy drawable we have absolutely nothing. This is just an interface and a pointer up. Just a minimal wrapper around Skia drawable interface. See how this looks. It's interesting because this is the first frame and we only packed one widget. None of the others were packed. This is a bug. Let's see what could have caused it. So we definitely called pack 0. This is what packed the window. So the initial draw time, we are setting this to 0 essentially, or this value anyway. This invalidated should probably be so really this will be set to infinity, like when we started drawing, we set this to maximum. I think this was the issue. Let's try again. Okay, so now we packed some widgets. Not all of them, only some. Probably some of them were off-screen. Could have been it. So window was packed, root machine was packed, that's good. Those are the most important ones. Some locations were packed. Toolbar was fully packed. That's good, because it's on screen. Not all of the text entries were packed, but this is probably because they don't have texture bounds. So it can be excused, that's not a big issue. Okay, there is one. Okay, there are actually some buttons which are probably off screen, so they are not packed. That also makes sense. Okay, I have a bunch of notifications about invalidated widgets not found in draw cache, which shouldn't really be a problem. In the way we measure this is terrible with a set. Come on. This is not a problem because it doesn't cost us anything, really. This is not a problem anymore. Let's restart because we got rid of some of the noise already. Okay, so this is what we are rendering. Toolbar prototype button increment. Step in. And let's see what we have in drawable bounds. Okay, this is a rather large rectangle. It's very strange. Prototype button increment shouldn't be that large. So on the top level, dimensions are super large now. Find it. So prototype button increment. So this is the last object which was packed. this time measurement, we don't need it actually, because we are measuring it elsewhere. I think here. I think this is a better measurement, a better place to measure it, I mean. Let me restart. Okay, at least we are consistent. So if something's wrong, it's consistently wrong. So we allocate surface. We allocate surface, there it is. There is our surface. Proper size even. We're getting the canvas, clearing the canvas. Drawing this stuff and flashing these to the surface. It's not looking bad, but I guess we should do the whole rendering flow. So when we finish rendering something, we should actually record this information back. I will allocate a static map here. Let's call this frame request. So we are recording this time. Okay, this is probably why we didn't present anything, because only when we actually... So we actually have to pass this list of finished jobs, because here is where we actually do the quote flip.
L4B3 Shear says,
Sup?
Hey, hello. Just one thing we need to take care of is to clear the render times. So we are drawing some stuff. We can even hear clicking, so there is stuff happening on the screen. We're just not presenting it, because probably our compositing code is broken. I guess we have fairly high FPS, because we are not really presenting anything. Or maybe not. I have no clue. I guess we'll have to... I mean, we won't have to, but we can try the debugger to see what's happening. Okay, so here we update everything. We should probably do the same with overflow. Now, right now we are doing everything serially, but this updating, this can be super parallelized, because the drawables, they form a graph. So we can just walk this graph like from the leaves to the root and do all of the drawing. And those things, the overflow, this doesn't even form any tree, like each of them can be rendered separately. So the parallelism can be pretty high. This is a step that we are probably missing. Sorry. I mean this on draw, because we shouldn't really draw the cached texture here. Here we should actually draw the widget. I mean the draw cached. I mentioned there are those 3 points in the lifetime of the frame. So first there is the actual draw. So this includes the logic, like animation, and only actually record stuff. into skdrawable. There is the update. Where we are re-rendering the SK surface. And there is one more step, which, so this is this on draw. This is where we should just composite the cached surface. Let's assume that surface is always there. Let's draw it at position 0, 0, sure. Let's maybe quit. After the first frame. I just want to see and the console log from the first frame. So this is the widget tree. We are packing the widgets which are on screen. And then we are rendering them like in the topological order. So this is all good. And finally we are rendering the window. After the window is, updated, so we call this draw update. Okay, the names for this are actually terrible. So this is actually render. It should be called rendering. And then we have this last step, which is called draw by Skia, and we cannot rename this. So we may rename our draw to something like update. So there will be update, render, and then draw. Okay, it's still weird, but it shouldn't be that bad.
Yash Verma says,
Hey!
Hey, hello.
Please give a roadmap for a great gob.
Great gob. For some reason we are having a lot of these 719 by 719 sizes. It's clearly wrong, but okay. So this drawing, I will put another log line here so that you can see. So we have called this draw function only once, which is probably wrong. We should call this much more. Specifically when we are calling this draw cached. We should really find the cache entry for our widget. Or at least try to find it. Tiny fix. I mean, maybe this is wrong. Somebody should create those cache entries after all. Okay, so what we are doing here, we are asking for texture bounds for the current object. Makes sense. If we have no texture bounds, then we just call the actual draw function. Otherwise, we are checking the dimensions of the object on screen. Okay, we are doing way too much work here. The work that should, I mean, that probably is already moved over here. Yeah. None of this rounded stuff is necessary. Actually, so we have this entry. Where do we populate this entry? Okay, so we are automatically allocating those entries for all objects. Actually, no, we are not going to do this. We don't care about surface. When we want to draw a cached object, we just call Choppy drawable draw.
Saxon says.
Give me 10 of your knowledge, and I will be rich.
Okay, I don't know what to return here. I'm not deleting all of this code because I guess it's going to be useful soon. Okay, so this is what happens during the animation tree construction. Here when we call onDraw, I think we should have a segmentation fault here when I run this. Let me see. Because surface is initialized to 0, and we will try to draw this. Yeah, drawable. So we are asking it for bounds. And the recording is null, empty. Just out of curiosity, I would like to know what we are drawing actually here. Should be a path. Keepers. Anyway, so the thing is, our Choppy drawable needs to handle this case. I will actually print some lines so that we can see when this happens, because I suspect some of them go through fine and only some of them fail. Blah, create a list of render jobs. Oh yeah, okay, I see, that makes sense. So macro recorder includes a button, and that button is never really rendered. So it has no recording. So those bounds, I guess they should be specified in local coordinate system. You know what, I will make a lunch break, and when I come back we can continue fixing this stuff. So the to-do here is that some objects are never cached. If they are never cached, we should actually never render them with choppy drawables, actually. But okay, handle so in the life cycle, this life cycle of widgets where we had we had a draw step, we had a render step, and we had skia, so when we record this tree, we record it as like tree of drawables. And this allows us to execute this tree from the end, so that the drawables add leaves, they can render themselves. So I actually think that widgets which are not cached as textures, they should be eliminated from this process as early as possible. We should not be like managing dummy objects for stuff that is never cached. So this is where we clip off-screen objects. Non-cached objects should just include their drawing commands in the parent. Okay, we're making a breakdown. Something like that. So, see you soon. Alright, I'm back and we can continue. So the problem that we now have is that some objects, the ones which are clipped or shouldn't be cached at all, they still produce choppy drawables. And they should not, basically. Let's close this, all those consoles, sidebar, and let's continue. So here, right, when the widget is being drawn, when we are calling this draw cached, we should make a decision. Either we draw the object immediately, or we defer to the choppy drawable. Essentially this block of code. Oops. I guess that should help. Okay, we still have some bug, and let's see what that is. Okay, so we are recording drawing commands for prototype button. So we are here. We're calling this draw. Actually, yeah, we should call draw children here. Let's run this again. Let's see the debugger. Okay, now we have this pack frame. We're calling draw on the toolbar. Toolbar wants to draw its children. Here, okay, that looks good. Some C++ noise. Okay, we are calling draw children subset. Makes sense. Yes. And then draw cached. So the last path element is the prototype button here. This is also prototype button, I guess, yeah. So we are recording a command to draw a drawable. And we need to pass those bounds here. Okay, we just need to initialize them because our current implementation, it just forwards this responsibility here to the recording, which is not the right way to do it. We should return not entry root bounds. I think those should be local bounds. I think for this we should use the texture size. Okay, we are already storing them, we just need to copy them over. And this code is such a mess now. What's going on here? Okay, we finished drawing. I mean, I don't know why everything is 719 by 719. We will have to look into this. But it feels like we managed to record drawing commands for everything. We finished with the window and then we started to render. First we rendered the increment object, prototype button. When we've been drawing the rendering prototype button, we actually used the texture. Okay, so we have texture reuse. Then integer, then again under prototype button with the bleed of our texture. And this goes on and on and on until... Okay, so we are rendering the toolbar now. And toolbar contains a bunch of prototype buttons which are all rendered as textures. I see some debug code left over. But this auto canvas restore, if I understand correctly, then it means we don't need to save and restore here. That's nice. Anyway, we are drawing this drawable. Okay, so we are trying to draw a child which doesn't have a fresh surface. This is actually nice. And this is what we will do. So we'll just fill the rectangle. Cool, cool. Now this weird size, where is it coming from? What's that? It's crazy how much work is there in a single frame. So here we have our packing code, which seems to skip some of the objects which are probably off screen. Yeah, those connection widgets, some of them are packed, some of them are not. It's probably because where the camera is pointing. So I think here the positions are still good. But then we get the surface. So when we allocate surface, it's definitely wrong. Okay, so we are asking the recording for its bounds. It doesn't make much sense. Let's not ask the drawable itself, because we should manage this info ourselves. So let's introduce a new variable into our draw cache entry. There's another enough variables, so let's introduce some more. Okay, those root bounds. see how the sizes look like now. We are getting closer. A lot of them are 1 by 1 pixels. Understandably, because we haven't used the conversion from meters to pixels. Why don't we have them? This local to window. I think so. Hey, that looked good actually. Numbers, 13 by 13 pixels, makes sense. Cool. Let's see what's happening here. Okay, we are rendering one of the locations. It's a location that contains the delay object. It's fine. So we are trying to get the canvas for the surface. There's probably something with this surface. Drawable bounds, they don't look great. Empty. When I print those bounds, I think it makes sense to do that. And this is kind of strange to me because the way we get those signs is we're actually asking in the widget for texture bounds. If the widget says there are no texture bounds, then we will skip it, but otherwise we will try to render it. Okay, maybe this is it. So we are checking whether the object intersects or not. With the screen. This is a piece of code that registers the new job. Okay, this always returns an empty option. So how are we caching this thing? That means locations should never be packed. And this one is. And this cache should only exist for objects which have location, the texture size. Okay, for cleanup, I will remove those two from widget 3. Now we don't need to copy anything. But actually what I wanted to do is I wanted to make sure this entry is set to null when there is no texture. And to do that I need to move the texture size computation a little bit earlier. Let's call this node. Okay. So now we shifted this stuff here. Essentially, we are computing the position of each object, wherever they are. I think we could actually skip objects which are outside of the viewport here. Because we are searching the tree, the widget tree here, we know the bounds of the widget, also in root coordinates, so probably this is the place to something like that. Because when we are doing this here, I feel it's a little bit too late here. But okay, so we have step 3. Get lag. Both lag and render time, they require entries. Okay, I think this should be always correct, because we only pack entries which have the cache entry. I mean, widgets which have cache entry. A quick check. Probably forgot about something. What was that? Oh yeah, I'm actually following the path to the parent. Let's start with an empty path and then Okay, we have to reverse this. Come on. We need to do this after this stuff because the tree needs something. Okay, so when the tree will have size 1, after we insert the first element, this will be 0. We'll push it. It will work. Or maybe let's do it like that. Oh, okay. Where is the next crush? We are really getting closer, trust me. We soon should see a window with something. Yeah, get lag, empty, because of there is no entry. Yeah, what is the lag of something that is not part of the rendering tree? I guess if an object has not so those objects can still be invalidated though, the ones which don't have any textures. So they should trigger the re-render of the parent element. Okay, I think this is okay. Yeah, again, render time. We don't care about this. Have you seen that? There was a drop of color there. I guess if we remove the early return from paint function, I will just comment this out because I may want to re-enable this in a moment. Some things are working. So our new rendering pipeline is doing stuff. I will interrupt this. Short break and then we can continue. wondering what could be wrong here. It's clearly something with matrices. Let me run this. When I stop this, let's go back to the previous frame. Okay, so we have a bunch of objects and we are recording their render times. See? Lag values are low, but we haven't looked at the lag values yet. So that was our widget tree. So when we record drawing commands for window, yep, those are the window dimensions, and on window we are drawing those objects. Trees root machine, a bunch of connection widgets, and a toolbar. So it's not exactly the correct pixel value, but this is because of rounding. So the root bounds should actually be rounded up, so that's fine. I wonder why connection widget and toolbar, why do they have so large textures? When I print the tree, I will print the dimensions, the bounding boxes of all of the objects. Lag infinite. Phew. It's a big lag. I can then use the metric coordinates here. Actually, the first frame is the most interesting one. So I will bring back our stopping. We just need to fix the positions of widgets, and then we can start working on multi-threading. Blah blah blah. And this is the tree. Now it's kind of lengthy. I need to actually decrease the font size so that you can see it. So window, local coordinates with 19 centimeters height, 9 centimeters. Root dimensions look like that. Then we have a machine. The machine is definitely larger than that. But it was probably clipped. I'm sorry, the text is super small, but otherwise I don't see anything. So here we compute, those are local bounds and root bounds, but here we're actually clipping them. And
Knight says,
Hey, everyone.
Hi Knight. So root bounds are clipped. Okay, so here is a delay object. Okay, well, why is delay not cached? Delay should be absolutely cached. And the location apparently is cached here. 100 by 100 centimeters, what? Okay, let's start. The root machine size. The local size of the root machine seems to be wrong. It's the same as the size of the window. Let's find it. Not test base. So machine itself doesn't specify any texture size. But it does have a shape. And yeah, the shape of the root machine is actually 100 by 100 pixels. Centimeters. I think our tree traversing code is wrong. We shouldn't ask parent widget, we should ask the widget for its size. That was a bug. Should be better now. Okay, we've seen something there. Okay, I think something is wrong with the toolbar, and we also seem to have something definitely changes when I move the mouse over the toolbar, so I guess this huge color blob is our toolbar. We should also have some objects here. Check this out, I can actually move them even. Now the dimensions of the window, they look good. The dimensions of the root machine look better. This is probably because of clipping. Cool. Location is not cached. Nice. And the delay has a proper dimensions here. Top right, bottom left. I guess that's fine. That also looks good. I want to see what's happening with the toolbar. Okay, this looks perfect, right? So those are the correct dimensions for the toolbar, about 5 centimeters high, compared to window, which is twice as high at 9. Root dimensions are also looking good here. I mean, mostly. It's minus 300. So this is a little bit weird. Am I transforming this correctly? It looks like I am not including the transform from the parent, because the toolbar should actually be centered. So this is fine. It's gonna be negative here and positive here. But the root position shouldn't go into negatives. It should be centered at 308, almost 9 pixels. It seems like this is not engaged. Know why. Yeah, this check is wrong here. Let's go do this myself. I think this is actually my favorite part, when things are almost working and we're just like removing the last bugs. And you can see glimpses of stuff, moving again. I mean, right now you cannot, but... Okay, let's fix the toolbar. Something's wrong with the toolbar position, I guess. So we will stop it, we will inspect the widget tree and see where we are screwing up. It's crazy how much work we are doing each frame. Okay. So here is our window at 19 by 9 centimeters. It's part of the frame, meaning it is going to be displayed. So this is our root machine. It's very large, but it's actually clipped to the size of the window. I mean, it's not even clipped. It's actually displayed in the center of the window. Anyway, let's go to the toolbar. This one looks great. For some reason though, it's not being rendered. When we draw it at position 0, 0, that should still actually draw it. So we should still see something, even if this is wrong. So we are recording drawing commands from the end. So we record drawing commands from the toolbar. And when the time comes, we're actually doing the rendering. Okay, so the toolbar contains a bunch of those drawables. Which can be drawn anywhere, really. We don't care. So when we draw our surface, we will always draw it not at 0, 0, but at its local coordinates. We basically want to fill the local bounds, this stuff. Yeah, it was good. We want to transform from surface bounds into those local bounds. Let's go for that, the default option. Okay, our matrix doesn't matter. And also they say it's top left corner at XY. We're using bottom left origin most of the time. I don't see any mention of origin. Okay, so we will use the same trick that we used before here. Okay, I can also do that. So let's forget about matrices for now. Let's just copy this part. Root bounds left and top. Let me just temporarily draw everything using red bounds. Oops. I mean, the canvas and the root machine seems to be drawn correctly. Yeah, it definitely should work in local bounds. I have no idea what's that, what's here, what's here. Maybe this is the timeline, maybe some of them are. I think something's broken. Something related to the size of objects. Let's do this trick with matrix inverse. Something is wrong here. We can fix this. We just have to print the coordinates and eventually we will see where the issue is coming from. So annoying. So we have this huge log. We can focus on the toolbar, for instance. So when we are drawing the toolbar, we are drawing it at these coordinates, x and y. I'm not 100% confident that this is the right thing. I guess I can mess with the canvas because drawables will restore everything still. I think right now we should see some red rectangles, but I don't see any of them. I wonder why everything is black now. Let's clear the canvas before we draw anything. White, that's fine. So when we're drawing the window on the top level frame here, we're also drawing a rectangle. I don't see this rectangle, maybe it's outside. The local bounds, who knows? Okay, I have a theory. Our canvas has absolutely no transform. Because we are applying transform in a totally different place. I think we need to scale it. Okay, now it looked better. I can switch from fill to stroke. Have you seen that? I mean, I've seen them. They were there for a second. again. For a very brief moment. Okay, this scale, this is what's messing up stuff. So this is a fresh canvas. Yeah, I can do reset matrix before every draw. Isn't that nice? Okay, the rectangles are actually drawn in good positions now. Almost. Actually wonder what are those. So maybe those are objects which we are for some reason drawing at wrong positions. And those actually could be the connection widgets. They look like horizontal connection widgets. See here, we have two connections going to those keys. And those are those. And then one which is folded. This is this one. And the one below the timeline. So I could even position them here. Okay, now VS Code crashed because I was probably printing too much. Okay, this top level frame can we move? The widget tree probably also remove. Or maybe we can print it every 10 seconds. And this recording, don't need that. Actually, this is something that we will need. Offsetting objects so that they fit within the surface that we are recording. So we have an object that we want to record, we know its bounds, we already have computed them in previous steps, even before packing. So here we have these local bounds and root bounds. We should leave it to do here. So right now, when we have this recording, what do we do with those matrices? What's that? And this canvas is a fresh canvas, we don't need to concat anything. We can just set transform to n. Okay, we have the same issue. So I can either use offset here, but I could also when I render this recorded set of commands, I can offset them here when I play them on a canvas, on a surface. So what are the overloads that I have? Or maybe that should be bottom, I'm not sure. Should be minus left. That was sudden. It's not entirely correct. I mean, we're probably not invalidating stuff like we should. Let me skip this rendering. You don't want to print too much stuff. And there is a disconnect between where we draw these surfaces, for example the toolbar. Or maybe the issue is somewhere else. It was very weird, even though I keep my finger here, I mean my mouse, I have to kind of move it. For the kind of update to happen. Yeah, and this one. So here is a prototype button, which has a child, which is this timer object. For some reason this timer object is offset a lot. So here, prototype button, it should be at position 312, and the child also 312. It's probably around here. For some reason it's way outside. Also, this situation is strange. Those objects are moved kind of twice. Okay, so what happens when we try to render an object to cache it? We have its root bounds. We know this is correct because we can check this in terminal. Those numbers make sense. Like this delay. The delay should be positioned in the same position as the prototype button. It should essentially overlap with it. So I know how large is the object. I can round its root position to get root bounds rounded. This tells me how large the texture do I need. And then I can play back the recording on this texture. I decided to do it here rather than here. Where was it? Maybe I should actually use the other approach. This changed something. Just have no idea. Okay. Apparently when I invalidate some object, it updates and suddenly it's correct. Okay, I think I need to use this scale check that I commented out before. Okay, so things that we are still missing that are causing some weird behaviors. What do we have to do? Plenty of stuff into those. I think one of the problems is that we are avoiding redraws a little bit too much. Here's an interesting case. When I resize this, it looks like the offset. I don't know why this object keeps moving to the... It's like it's sticking to the right edge of the screen, the toolbar. This is a very interesting bug. It should tell me something. Okay, one thing I think we should do, I think this is the maybe the most important currently, it's to take care of the animation phases. So if an object wants to keep animating, we should just keep refreshing it. Pretty much. So after we handle animation phases, the next point on the list is clearly the scaling. Scaling doesn't seem to work. And by scaling, I mean that when an object is rendered at some scale, right, like now, when I zoom in, right, that scaled representation should be drawn in the correct position. It should be pixelated, this is good. The pixelation is great. And it's actually even growing, but the position is wrong. This is drawn at the wrong position. So this is something we need to fix. I think this will also fix the toolbar position. Right. After we do those things, then we could request resized widgets to be redrawn. The same stuff that we used to do here in this commented block of code. That stuff we already copied over. Matrix root bounds. Okay, so right after we call draw, this is what we used to do. We're basically making the object invalidated immediately if it's animating. I'm removing most of these commented out code because we don't need it. Okay, so when we are here at this point, we should be back to back in the working state. We will not be finished because our goal here is to actually switch to a render job system. And even when we get there, we have a lot of things to clean up. One thing I'm thinking about is to not include widgets which are not cached in the tree at all. I don't know if we even need them. Okay, so maybe there will be lots of cleanup here. This widget tree, it feels redundant. And it's like terribly named. Or this widget tree. Like one thing we should fix is that widgets should have pointers to their parents. I know widgets are super small, super tiny, but really they have to be drawn anyway. So I was trying in the past to create a widget system which would be where a widget could be rendered in multiple places. But this is what caused me to create the widget paths. I'm not sure if this was a good idea. So this is another thing that could be probably removed. I think this widget tree could be removed. Or do something with it. Maybe not removed, but remove redundancy. It's also pretty awkward to work with those trees, like tree entries, tree nodes all the time. Another thing is that the three phases of rendering, they should be not separated, but they should be put next to each other so that you can see, oh, how this flows one into the next. And the phases are so we'll record the drawing commands. So this is this recording. By this I mean from the perspective of the widget. So within widget we should have widget record function, which will take care of this stuff. And then we will have widget render. And the final one, which will actually draw this. So this is called the draw cached right now, I guess. So there should be a bit of code in widget to handle the update logic, then another piece of code to handle the render logic, and then another to handle the present. So the code will be moved out from this function.
Yash Verma says,
Hello.
Hey. You came close to the end. I'm just like recording to-dos probably for the next stream. But we managed to get our rendering system to run. It can actually almost work. It presents a low resolution version of what we used to have some time ago. And it kind of breaks when I move stuff. As an experiment, I want to try something. So I will always execute this path, which should fix all of the rendering. It should fix everything. Yeah. It's crashing because we are probably kind of allocating too much stuff somewhere. I don't know, we definitely have some memory leaks. But okay, just a sanity check indicates that we're good. Like we can still draw stuff correctly. Okay, so this is our plan. Yeah, I cannot come up with anything else that we could add here. The cleanups, there will be just so many cleanups. Another one is going to be that we will have to move the frame packing and execution. Maybe not separate file, but we should move it away from Linux specific code. A separate file would probably make sense because this is fairly complex piece of machinery. Those surface positions, why are they wrong? We are using the draw matrix. Which will only update when we pack an object. this has to be related to this matrix. Maybe we should update it always. I mean, even if it's not packed. Let me see. It's definitely better now. I think we we fixed something. Scaling still messes this up. These two donuts also included here. You know what, I really feel like we should use rect to rect here. Oops. Let's call this R2R. So this is one variant. We will try that. I feel there is something with this height. Nope. The weird thing is that okay, I shouldn't use root bounds, but local bounds. Really strange. Yeah, feels weird. Okay, now this looks good. I mean, it's crashing, but it seems like objects are where they should be. Most of the time. It's fun that we are continuously redrawing some of the rectangles, but some of them are just kept because they are part of the textures that we are then kind of drawing on top. So this macro recorder has its own miniature texture with a baked-in rectangle. When I point it, it will update it. But the button is also still kind of unrefreshed. It's very weird. I don't know why the macro recorder starts at the wrong position. This is something we should check. Okay, we fixed this, so why is macro recorder initialized on the wrong position and why are we crashing after a couple of seconds? Maybe this will go away when we fix other things, so this we will think about this last. this rect to rect fixed. Actually fixed many things.
Galarian says,
How long have you been coding?
It depends what you mean. Like today or like in my life. So the coding today, definitely too long. Actually, I'm ending now. I'm just like listing the to-dos, the stuff that I will have to fix on the next stream.
says, Hello Galarian. This is a reminder that TTS only works in English.
Oh yeah, that's true. Alright, time to finish for today. Thank you for watching, whoever watched, and see you on Friday. Bye bye.